Hello, good day everyone. Let me just record this lap on AutoScaling as we agreed yesterday, since we lost track of the recording at some point, so that we can all watch and redo. And for those who didn't attend the lab yesterday, you can also watch and catch up with the AutoScaling lab. So just a short rundown on Amazon or AWS AutoScaling, as we discussed yesterday, is a tool or a service that gives you the opportunity to monitor your applications and configure them to automatically scale in adjustment to traffic or workload, such that they can remain reliable and responsive to the traffic that comes to the applications. So on AWS, we have auto-scaling for EC2 instances. As you can see here, for the ECS task, for Amazon DynamoDB tables and indexes, and as well for Aurora. So you can configure auto-scaling for all these different AWS services. I'll just go straight to the lab and carry out the lab with you. So just a rundown on what we're going to do. First, to create an auto-scaling group, you need a launch template which carries the configuration of the instances that your auto-scaling group would spin up when it scales out. And for you to have a launch template, you need to specify, amongst other configurations, the Amazon machine image ID, the AMI. So to do that, we're first of all going to launch a web server on AWS. And we'll do that with the help of CloudFormation and the template that has been shared in the lab guide. And from from the web server, we'll create an image, after which we'll use that image we'll use the image ID to specify in the launch template, after which we'll then create the auto-scaling group and then test it. Aside that, we're also going to create security groups, both for the auto-scaling group and for the load balancer that will sit in front of the auto-scaling group. So just going straight to the lab, I'll start by creating a CloudFormation stack. So I'll click on Create Stack here. And I'll choose an existing template since I have the template already, and we all do. Then I'll choose to upload the template file. We don't have it in S3, so I'll upload the template file. When I click on this, I'll then click on Choose File. It will take me to my folders, File Explorer, and then I will just choose this EC2 Auto-Scaling lab file, which is the YAML template or the CloudFormation template. I click on Open to upload the file. And now click on Next. Then just move up this Zoom link. Yeah. So now I'm going to enter a name for the CloudFormation stack, and I'll just call it Use the Lab Auto-Scaling Server, because this is also going to be the name of the web server that we will deploy. I'll scroll down. The AMI ID, I'll leave it as that's been specified in the template. For the instance type, I'll click on this and change it to T2 micro, which is pretty eligible. And then for my IP, I'll go to Google and just search for what is my IP. So I can get the IP address of my local machine, which is here. So I'll copy this address and I'll paste it in this box here. Then I add /32. So that's how you get the IP address of your local machine. For the VPC, I'll choose my default VPC, which is the one that came with my account. And for a public subnet, I'll choose this public subnet. So I have several subnets here. This is a private subnet. Just make sure you choose the one which is a public subnet. And I'll choose this one, user block. It's very close to that of my VPC. So I click on Next from here. And Next again. And scroll down till I click on Submit Then I wait for my stack to be deployed. So you see create in progress. It's being created now. And when this creation is complete, we expect to see an EC2 instance. Yeah, we can already see it here. It says pending. So when the step has been completed, the instance should be running. So the CloudFormation template has, or the CloudFormation stack has deployed the instance for us. So back in the EC2 console, this is the Tuesday AutoScaling server now is running. But I'll just refresh to make sure that, yes, my stack has been deployed completely. All right, so back in the EC2 console, my instance is running. I will just hold on for a while so that it initializes completely, and then I would copy its IPv4 DNS, public IPv4 DNS, and look at their page to actually prove that it is running and has installed the necessary software that we need. So apart from the web page, I think the other thing is going to install is the stress tool, since we are going to use it later to spin up or to use up the CPU of the instance. So I'll just hold on and pause the video until it's completely initialized. So my instance has completely initialized and has passed the 2 and 2 checks. What we'll do now is to click on the instance ID so that it expands the instance details. And I'll scroll down here to copy the public IPv4 DNS by clicking on this. Then I will open a new tab in the browser and paste this IPv4 DNS to see the web page. And yes, this is what we expect to see. This is the instance that we have launched. And we can see here that the private IP address is this. The instance is hosted in US is 1D. And this is the instance ID ending in 74EB. So yes, the instance ID ends in 74EB. This is the private address, and indeed, the instance is hosted in US is 1D. To see that, I'll just go back here, and you can see that it is hosted in US is 1D under availability zone here. Okay. So now that is done, the next thing to do is to create an Amazon machine image from this instance. And how to do that, I will select or check the instance, select it, and I go to Actions. Then I click on Image and Templates, click on Create Image. And then I'll give a name, the image to be Tuesday Lab AMI. Okay. And I'll just give this in the description, Tuesday Lab AMI. Scroll down, move to the right and click on Create Image. Okay. Now I have this error because I already have an image with this name. So I'll call it Tuesday Lab 1 AMI. But for you, you shouldn't have an error since I did the lab yesterday. So I scroll down, I click on Create Image, and the image has been created. How can we see that? We scroll down to where we have images, and I'll click on AMIs. And I can see my Tuesday Lab 1 AMI here. So you see Tuesday lab AMI that we used yesterday, and that's why I refused to give the same name for the image. Okay, so we've done two things already. The next thing to do is to create a security group for the AutoScaling group. So I'm going to scroll down to network and security here. Click on security groups, and then I'll click on create security group. So I'll give a name for the security group to be Tuesday Lab ASG for AutoScaling group SG. Tuesday Lab AutoScaling group security group. I'll copy this name and use it as a description. It is in the default VPC, so that's fine. For the inbound rules, I'll just add one rule, which we'll edit later. So add one inbound rule. For the type of traffic, we're going to say all traffic. So we'll allow all traffic from now and from anywhere IPv4. So under type, we choose all traffic. Under source, we choose anywhere IPv4. We'll scroll down and we click on create security group. Okay, the security group has been successfully created now. So we can go ahead and create our launch template, because we're going to need to specify the security group as well as the AMI in the launch template. So to create a launch template, under instances, if you scroll down, you'll see launch templates here. So I'll click on launch templates. And I'll click on create launch templates. I'll give a name for the launch template to be Tuesday Lab. So Tuesday Lab 1 template. I'm putting 1 because I already have a template with the same name. So I'll copy this name and use it as a description. And where we have auto scaling guidance, I will check this box that says provide guidance to help me set up a template that I can use with EC2 auto scaling. So check this box. Then we scroll down. Now we need to define our configurations here. And the first thing we need to define is the application and operating system images. That's the Amazon machine image. So we'll scroll down where you have recent. We click on my AMIs and owned by me. And then when we click that, if you have just one AMI, it should just appear here. But since I have several, I would click on this drop down arrow and scroll, and I will then select my Tuesday Lab 1 AMI. Okay. Now I've selected the AMI that this launch template should, or the auto scaling group would use. For the instance type, we're going to choose T2 micro. So I'll scroll down and choose T2 micro. So all the instances that the auto scaling group would spin up when it scales out will be of type T2 micro. I will scroll down to key pair and I will choose my Tuesday Lab key pair, which we should all have, or any key pair you're using. Then I'll scroll down to network settings. We're doing nothing about the subnet, but we leave select existing security group checked. And here now we're going to choose the security group we just created, the auto scaling security group. So I'll click on this drop down arrow and I would select the Tuesday Lab ASG SG that we created just a while ago. Okay. When I scroll down to advanced details, I would expand the advanced details by clicking on this drop down arrow, and I scroll down to where we have detailed CloudWatch monitoring, and I would enable that. So you want to enable detailed CloudWatch monitoring because the instance metrics need to be monitored. and we'd see. So when you enable that, you scroll down now and you click on create launch template. Okay. So it's a success. The launch template has been created. Now the next thing to do is to go ahead and create our auto-scaling group. We already have all the things we need for the auto-scaling. So I would scroll down on the left, right till the end, where you have auto-scaling. I'll click on auto-scaling groups, and I'll click on create auto-scaling group. For the name of the auto-scaling group, I'll call it Tuesday Lab ASG. Tuesday Lab auto-scaling group. And when we scroll down to launch template, you see we need to now specify the launch template we want this auto-scaling group to use. So I'm going to click on this drop-down arrow here, and we select our Tuesday Lab 1 template. Okay. Then you scroll down and click on next. Now, for the instance type requirement, we have the option to override what we had written in the launch template, but we will not do that. Remember, we chose T2 micro in the launch template, so we'll just let that be. We'll scroll down to network settings. The VPC is our default VPC, which is okay. Now for the subnets, we're going to click on this drop-down arrow and select 4 subnets, public subnets for availability zone. So I'll choose USS 1A, USS 1B, 1C, and 1D. The public ones, you can see that this first option is the private one. Don't choose a private subnet, a public subnet. Okay, when we choose that, click on next. And now we have to configure our load balancer. The load balancer is going to sit in front of the auto-scaling group, and it should accept traffic from the internet. So it should be an internet-facing load balancer. So under load balancing, we are going to click on attach a new load balancer because we have not created one from before. So this load balancer will be created for us and attached to the auto-scaling group. We scroll down. Now we need to choose the options. So we're attaching a new load balancer, and we want an application load balancer. So we leave this checked. The load balancer name, I'm going to edit this to be Tuesday Lab LB, LB for load balancer. Load balancer scheme, I'll choose internet facing. We want this load balancer to accept traffic from the internet. And yesterday, some people faced some problems because their VPCs do not have internet gateways attached to them, and so an internet-facing load balancer could not be deployed. So if you do this and you face an error at the end, you should check to make sure that you have an internet gateway at the level of your VPC. So internet-facing load balancer, you scroll down to the network mapping. We had already chosen the 4 availability zones. So we scroll down to listeners and routing. Yes, we want the load balancer to listen on port 80 for HTTP traffic. And it should listen from, and it should forward the traffic to a target group. So we need to select a new or an existing target group. We click on this drop-down arrow and click on create target group because we have not created one before. And for the name, I'm just going to call it Tuesday Lab target group. Okay. So we scroll down then. We leave no VPC lattice service selected. This is a new feature. And then we scroll down to health checks. Under EC2 health checks, we are going to click on or check this box that says turn on elastic load balancing health check. So this is going to make sure that before the auto-scaling group sends traffic to an EC2 instance, it makes sure that the instance is up and healthy. In other words, the instance has passed the 2-on-2 checks and is able to respond or to handle the request. So click this box. And then we scroll down and click on next. We're going to leave these additional settings. It's good practice also if you're working in a prod environment to enable group metrics collection with CloudWatch so that you can see the metrics. You can using a dashboard observe the health of your instances from CloudWatch. So we'll click on next. And now we are going to be configuring the AutoScaling group policies here that will tell the AutoScaling group when it should scale out and the maximum number of instances it can spin up when it is scaling out. So under group size, we have to choose the desired capacity, and we see the desired capacity type is instance, number of instances. So the desired capacity is, we're going to leave it as 1. So we desire that 1 instance should always be running whatsoever. So 1 instance should always be running. That is our desire. So it's 1. And then under scaling now, we need to set our scaling limits. The minimum desired capacity means in a case where our desired capacity, in the case where the auto-scaling group is scaling in, we want that it shouldn't scale in to and shouldn't scale into a point where at least 1 instance is not running. So we'll leave the minimum desired capacity to 1. So even if it scales when there is no traffic, at least it should leave 1 running. We could have a case where our desired capacity is 2. So we want that, excuse me, at least 2 instances are running at a time. But if the auto-scaling group is scaling down, scaling in when there is no traffic, we want it to scale in and leave just a single instance. In other words, we could have 2 here and 1 here, but in this case, we're going to have 1. Then the maximum desired capacity, we're going to put 5. This means that no matter how much the traffic is from the internet, when the auto-scaling group is scaling out and spinning up new instances, it shouldn't spin up more than 5 instances whatsoever. So we don't want a case where it should create 1,000 instances because there is traffic. This also helps us to manage our costs better. Okay. Now under automatic scaling, we are going to choose target tracking scaling policy. So we want to set a policy. We want to tell the auto-scaling group to scale based on a particular target. Now, so the scaling policy name is target tracking scaling, target tracking policy. Now, what is the target metric that we want the auto-scaling group to scale in response to? Average CPU utilization. If we click on this drop-down menu, you have other options. It could be average network in, average network out, application load balancer request count per target. But in this case, we want it to scale out or in based on the CPU, the average CPU utilization of the targets. And we want to put the value at 25. This means that if the average CPU utilization of all the targets in the auto-scaling group are above 25, it should scale out. It should spin up more instances. This is the metric that the auto-scaling group will follow. So we'll scroll down. We'll leave the instance from up to 300. We scroll down. Click on No Policy. This is a new feature that has come into where you can decide on the behavior of the auto-scaling group when it is terminating instances. So in this case, we just choose No Policy, but it could be that it should first of all launch new instances before it terminates old ones, or it should terminate the old ones before it launches new ones, or you customize the behavior how you want it, but we'll leave it as No Policy. We scroll down, we click on Next, Next, Next again, scroll down, and then we click on Create Auto-Scaling Group. So our AutoScaling group has been created, and we see the status. It is updating capacity. After some time, we should see that it has launched a single instance. And I think it would go back to, if I open the instance, the EC2 instance console in another tab, we should see that it would spin up a new instance. Yes, and we can see that an additional instance has been launched here. This instance has been launched by the AutoScaling group. This is the one we launched using the CloudFormation stack this Tuesday, AutoScaling 7. But this one has been launched by the AutoScaling group, and we can see that if we click on the instance ID and scroll down to tags, you would see that this instance has been tagged by Tuesday Lab AutoScaling group. So it's an instance that has been launched by the AutoScaling group. All right, so our AutoScaling group is up and running. The load balancer too has been deployed. But at the moment, this load balancer is attached to a default security group. We would want to create a new security group for the load balancer, or edit this one. But let's just go ahead and create a new security group that will attach to the load balancer. So I'll click on security groups here at the side, and then I'll click on create security group, and I'll call it Tuesday Lab Load Balancer LB SG. Tuesday Lab Load Balancer Security Group. I'll copy this name and use it as a description. I'll scroll down. Of course, this should be created in the default VPC, but I'll add a rule here, an inbound rule. I'll add an inbound rule, and I'll say that this load balancer, because this security group is going to be attached to the load balancer, we want the load balancer to accept HTTP traffic from the internet. Yes, from the internet, but this case we want it to accept it just from our IP, the IP address of my machine, of your local machine. This is for security reasons, so that not everybody can be able to access your targets. So under type, I'll click on it and choose HTTP. And under source, I'll click on this drop down and choose my IP. What this means is that every HTTP traffic from my IP address is going to be allowed into the load balancer. We'll scroll down now to outbound rules, and we'll edit this outbound rule. Let's add a new outbound rule. We delete this one. So we want the load balancer to be able to send traffic then to our AutoScaling group. So we want it to be able to, when it receives the HTTP traffic from the internet, it should send it to our AutoScaling group. So here we are going to click on HTTP still. We choose HTTP for the type. And under the destination now, we'll click on this lens-like icon and then scroll down to choose our Tuesday Lab AutoScaling group security group. So Tuesday Lab ASG SG. Okay. And then we delete this first one. So when we look at this, what we mean is that the load balancer, because it sits in front of the AutoScaling group, should accept HTTP traffic from my IP address or the IP address of a local machine. It could be from anywhere, and it should allow this traffic to be sent to the AutoScaling group. So we scroll down and we click on create security group. Okay. Now the security group has been created. We're going to go and attach it then now to the load balancer. So I would scroll down on the left to where we have load balancing. I'll click on load balancers. And this is our Tuesday Lab load balancer. So I'll select it, click on actions, click on edit security groups. And here you see that the security group attached to the load balancer is the wrong one. It's the Tuesday ASG. We want the Tuesday Lab LBSG. So we're going to click on X to remove this one. Click on the drop-down menu, scroll down, and look for the Tuesday Lab LBSG, Tuesday Lab Load Balancer Security Group. So we'll select that one, and we'll click on Save Changes. Now the load balancer is attached to the right security group. The last thing we're supposed to do before testing our work is to go ahead and edit the inbound rule of the AutoScaling group security group. I did mention that we are going to edit that rule. For now, that security group accepts traffic from anywhere. So let me scroll down to security groups, and we look at the Tuesday Lab ASGSG. So this is the security group. Tuesday ASGSG is the security group for the AutoScaling group. I'll click on the security group ID to expand. And under inbound rules, click on edit inbound rules. So if we look at it for now, we'll see that this security group allows or accepts traffic from everywhere. This is not what we want. Now the load balancer sits in front of the AutoScaling group. So we want the AutoScaling group to be able to accept traffic only from the load balancer for security reasons. So we're going to delete this rule and click on Add Rule. Now, under the rule type, we'll say HTTP. Under the source, so the source of HTTP traffic that we want this load balancer, or which we want the AutoScaling group to accept, should come from the load balancer. So we'll choose Tuesday Lab LBSG. Tuesday Lab LBSG. So we'll do that with save rules. Now our AutoScaling group is set. So now we're going to test the AutoScaling group. This tab is the tab for the instance from which we created the AMI. So I'm going to close the tab. And now I'll go and copy the DNS name for the load balancer. So I'll scroll down on the left where I have load balancing. Click on load balancers. And I would see, you see DNS name here. So I can just click on this to copy DNS name. I open a new tab and I paste the DNS name of the load balancer. Because the load balancer sits in front of the ASG and sends traffic to the ASG, and the ASG then distributes this traffic to the target, we can access the targets directly from the load balancer's DNS name. So when I paste this DNS name, you should be able to see that we would access the web server or the instance that has been deployed by the AutoScaling group VALAN. We see here that with the load balancer's DNS name, we can access, as it says, Tuesday Lab LB something. So this is the load balancer's DNS name. This is not the IPv4 DNS of the instance. We can access that instance. So if we look at it here, Kinyuy, just to prove that this is the instance that was launched by the load balancer, we can see that the instance is hosted in US East 1D, and the private IP address is 172.1.10.17. So let's go back and compare this. So if we go back to our instances and we look at this instance that has been launched by the load balancer, you see that the IP address is 172.32.10.17, same as it is here. And if you also look at it, Kinyuy, the instance ID ends in 823A or 823A. You come here, you would see the instance ID 823A. And you can also see that this instance has been hosted in US is 1D. Let me go back here. So this is the instance that has been posted in US is 1D. Okay. So now we can access our targets from the load balancer. Let me go back to the web page. A stress tool is being installed in this target. So what we're going to do now to show that the load balancer or the auto scaling group is working and is going to respond, or is going to spin up, scale out by spinning up new instances, is to start up this CPU load generation. So I'll click on it a couple of times. And what this does is that it uses up the CPU of the instance. So when it uses up the CPU of the instance, it's going to exceed the 25% that we configured in our auto scaling group, and it will then cause the auto scaling group to spin up new instances. So after some time, I expect that new EC2 instances will be launched by the auto scaling group. So these are the instances we have for now, just one instance, and the one that was launched using CloudFormation. So I'll just refresh this again. Click on it a couple of times to use up its CPU, and then we're going to see that new instances will be launched. Okay. Let's go back now and observe from here. Okay, so it's been some time, and we can see that our auto scaling group has spinned up new instances here for us that scaled out. And we can see that all the instances is spin up are of type 2T micro, 2T micro. So if we go to the load balancer DNS here, just take note that this first instance that we are accessing was hosted in USS 1D. If I should refresh this page now, I should be directed to a different instance. This is like different people sending traffic to a website or requesting information from a website from different places. They are being sent to, or the load balancer accepts the traffic and sends it to the auto scaling group, which then directs it to different instances that handles the request. However, the instances will handle the request in the same way since they are made of the same AMI. So I'll just refresh this page. And you see now I've been redirected to the instance hosted in USS 1A. And if I refresh again, it has taken me back to USS 1D. Let's try again to see if it takes us. Yeah, now it has taken us to USS 1B. So this is AutoScaling in action. Now it has taken us to use this 1C. So all of those instances from the load balancer, this can then be like a contact link address, a domain for your customers to use to access your website. It will then be directed to different targets, which are instances at the back end handling the traffic. Okay, so that is it about AutoScaling. We are just going to clean up now. So first, to clean up, we are going to scroll down and delete the load balancer. Make sure you clean up, please. So to delete the load balancer, scroll down to load balancer, click on load balancer. Then I'll select our Tuesday lab load balancer and then click on delete load balancer. And I have to type confirm. Then I delete. The load balancer has been successfully deleted. After that, just below it, we have target groups. So I click on target groups and I delete the target group. So I select it, click on actions, and click on delete target group. Yes, delete. Maybe that was too fast. Okay. First, I'm going to click on actions and let us try again. Now it has been deleted. That was a little bit too quick because the load balancer was probably still being deleted. Okay, so the next thing now is to delete the AutoScaling group just below. I click on AutoScaling and I select my AutoScaling group, click on actions, delete, and yes, I need to confirm that I want to delete this. And we'll allow it to be deleted. You can see that it's deleting. You just give your AutoScaling group some time to delete completely. Because it has to delete and terminate. While it's deleting, it's terminating all those instances. So if we go to EC2 to instances, you would see that the instances that were spinned up by the AutoScaling group, as we can see, have been terminated. The instances have been terminated, and the last one is being terminated. You see, it says shutting down. So when that's going to be done, when the AutoScaling group is done deleting, the last instance will be terminated. That's probably what it's doing now. Yeah, so it's shutting down the next instance. This one. Okay, so the AutoScaling group has completely been deleted. And if we refresh here, we'd see that the last instance has been terminated. So the last thing we do now before deleting the security groups is to delete the CloudFormation stack, which will terminate this last instance. So remember, it was deployed using the CloudFormation stack. So I go to CloudFormation and I just click on delete, confirm delete, and the stack is going to be deleted. We see delete in progress. Delete in progress. And if we come back to EC2 and refresh, we'll see that it is shutting down the last instance. Yeah, which was deployed using CloudFormation. So now the CloudFormation stack has been completely deleted. So we've cleaned up. The last thing to do is to come to security groups, even though you don't pay for this, just to keep a clean environment. So we're going to delete these two security groups. But first, we'll open them up, each of them, and delete the rows. So delete both the inbound and outbound rows, because if you don't, you won't succeed to delete the groups, since the rows, the rule of one security group is referencing the other security group. So you delete the inbound and outbound rows. And then now, once that is done, you can select both the user lab ASG LSG and the user lab LBSG. Click on actions and click on delete and type delete, confirm, and delete. That is done successfully. Okay, that's it about the lab. I hope you were able to go through it. Thank you all and see you next time. Bye.